So the nice thing about Lambda is that you can just write these very nicely logically isolated pieces of code that, yes, you take responsibility for them, but you're talking about 20 lines of code or something versus an entire service or an entire cloud environment. So Evervault, and by extension AWS, takes responsibility for making sure the data centers are secure. They've got whatever armed guards and attack dogs and all this kind of stuff. But from a developer's perspective, all you have to worry about is that 20 lines of code that you're deploying.
Is Lambda PCI compliant then?
All of AWS, or pretty much all of AWS, is PCI compliant, but there's what's called a demarcation of responsibilities. So AWS are responsible for one part and you're responsible for the other part.
Welcome to Cloud Security Podcast. Today's episode, I have Sean. Hey, welcome to the show, man. How are you?
Good. Yeah, it's nice to meet you.
Nice to meet you as well. Could you tell us a bit about yourself and a bit of your background and where you are these days, man?
So I'm the founder of a company called Evervault. My background is software engineering, built a bunch of kind of SaaS products and so on, and just became really obsessed with kind of the intersection of infrastructure and security. So started Evervault about 5 years ago. We kind of had this thesis that the best way to implement security, especially when it comes to data, is very strong encryption and kind of centralized controls, and what we call that as a vault, so hence the company name Evervault. So we want everybody to collect, process, and share sensitive data, always have it encrypted or tokenized as it's defined in payments, which we can chat about in a bit. But what we discovered over time is just that from a security perspective, if you're selling into a CISO or something, you want a tool that you can kind of sell to them. The engineers don't need to necessarily be involved. But if you're looking to kind of vault or tokenize all of the sensitive data that's being used within a piece of software, you need the product engineering team involved. So figuring out the incentives there was pretty interesting, where we basically made the decision that we're going to start off, although we want everybody to tokenize all kinds of sensitive data, because all the sensitive data that companies collect is there's only a handful of primitive data types. So if you take something like name, email address, social security number, basically everything stems from that. If you want to run a credit check or process a payment or something similar, you only need maybe couple dozen pieces of data. So we're basically trying to pair incentives with those pieces of primitive data with a piece of kind of value that you get. So we decided payments was the natural first fit there. Because there's a bunch of data you can get from the card networks. There's a bunch of compliance and security advantages that let you launch a product. And it also improves security at the same time through strong cryptography.
Actually, for people who don't come from that field, and I imagine some people are just technical people, to your point about product engineering people and even the product security people, what industry is it part of and what does it help that industry do, I guess?
I think broadly payments is part of financial services. It's obviously a very broad bucket. But within payments, then you kind of have to narrow it down, especially from a security perspective, into the type of payment. So there's all kinds of different payment types, and every month or every year there's a new startup that's kind of pushing some new type of payment. But generally speaking, for most consumers, it's either credit card or debit card payments, which historically have been very, very kind of driven by compliance requirements. So PCI compliance was basically defined by the card networks or the PCI Council, probably about over 20 years ago at this point. And I think as a result, that's driven a lot of the engineering work that goes in there. And as a result, people haven't really innovated very much. They're kind of very much doing checkbox compliance, encryption at rest, all these kinds of things that are obviously important. What we've seen now is that as security is kind of becoming a feature of the payment products with things like stablecoin payments or managing wallets, the keys are the money. Historically, a credit card number is kind of a way to authenticate a payment and kind of tie a payment to a particular person. But in digital assets or stablecoins, whatever you want to call them, the key itself, the 32 bytes or 64 bytes, is the money. So if that goes missing, it's a way bigger problem than a credit card going missing, and you can cancel it. So I think as a result, we're seeing this shift from compliance-driven security to kind of hardcore infrastructure security when it comes to crypto or Web3.
Oh, right. And so would you say, in that new world of crypto and Web3 and how payment security works these days, how is it different now? Because obviously you guys are using AWS quite a bit, building on that. What happens behind the scene, I guess, in terms of, making this possible?
Yeah, so I think the big thing within digital assets is trustlessness, which...
Is that even a word?
I don't know, it is now.
It is now officially, yes.
Yeah, so I think there's this kind of concept within crypto of custodial and non-custodial wallets, where a core feature of crypto is that you are in control of your own assets or your own money. And then as a result, even from a consumer perspective, generally speaking, they're much more sophisticated. That's starting to change a bit now that there's these kind of consumer peer-to-peer payments apps built in stablecoins. But basically, companies start off building a self-custodial app where the wallet lives in your phone. You do Face ID to authenticate a payment or something similar, and that works great. But the problem is you either lose your phone, not everybody, but a lot of people lose their phones. You want to do something online, you just want a better user experience. You don't have to, export a seed phrase to iCloud Drive or Google Drive or whatever. And then as a result, companies want this kind of trustless compute base to be able to do things with the keys. So for Evervault, we use AWS Nitro Enclaves. To give a bit of kind of context on that, AWS Nitro system is the technology that they use for their hypervisor, basically. So it's way more efficient. You don't have to run a hypervisor on the machines that you might be running an EC2 instance on. And Nitro Enclaves is a product that they released that gives you, as a developer, way lower level access to the kind of security guarantees of a Nitro Enclave. So you can basically write any piece of software that fits into a Docker container, more or less. You get guarantees that the code that you're running is the code that you built, so you can cryptographically verify that. And then I/O is extremely restricted, so you can't just send requests to a third-party API without explicitly turning it on. And then as a result, if you're sending a private key into an enclave, you know that the only thing that's happening to that private key is it's being processed by the code that you or your engineers kind of wrote and deployed. And in that case, you kind of get these really, really great security guarantees that you wouldn't get if you were just using EC2 or...
Right. So you actually can go a little bit more lower level to the hypervisor level as well. That's kind of where you're coming from. So maybe the message here for other financial organizations that are using just an EC2 instance, which is a T2 micro or T3 micro, if they were to use a Nitron one, they get a lot more access to the lower level encryption as well as they want to in terms of on the hypervisor itself.
Yeah, and that feature is called attestation. It's probably the best feature that Nitro Enclaves has. Is you can basically request a document that contains a signature signed by AWS that this code that's running in the enclave is the code that you wrote. The big problem, though, is you need really good engineers to be able to implement this stuff. Most people who are building financial services software, they're really great at low latency processing, computational correctness, because if you move $100, you want to make sure that $100 shows up on the other side. But the kind of low level hypervisor and cryptography knowledge isn't something that most engineers have. So what we do is we use that underlying primitive, but we abstract it massively. So your average developer who's used to working on Java apps or something in financial services can just take that application using our tools, convert it into a Nitro enclave, and they just don't realize it. So it's kind of like Heroku, what they were doing 10 years ago for normal compute. We kind of do it for Nitro enclaves.
You guys would have to be PCI compliant as well, even if you're using Nitron. And to your point about PCI compliance has been there for over 20 years. I don't think the auditing capability, auditors per se, have not been able to develop a lot of that nuance to, hey, now you kind of use the supervisor layer of encryption. I mean, the whole layer of moving PCI to cloud was one movement. I feel like this is the next level of movement we're talking about. How are you guys, I think you kind of mentioned AWS Lambda somewhere as well when we were talking about this earlier. So what is AWS Lambda doing in all of this, and how does this help you?
Yeah, so PCI has always kind of been probably about 10 years behind what the latest standards are. So there's a new PCI version 4 that is a bit more cloud native. But the problem is, as you mentioned, there's way more stringent requirements put on companies, but at the same time, there's a massive shortage of QSAs, which are basically PCI auditors. And then as a result, it's just really hard for these firms to hire them. And as a result, they're doing way more audits, and they just don't even, whatever about the knowledge, they just don't have the time to be kind of going very deep in these things. So I think as a result, a lot of companies have taken the approach of, you're still in scope for PCI compliance, but you just massively descope. So PCI has, for example, about 400 controls in a full level 1 ROC, which is the most extensive form of a PCI audit you can do. Most companies then, they just decide, we don't want to deal with all 400, we're going to descope it. And using products like ours and tokenization in general, you can reduce that scope massively down to the equivalent of using a payment iframe on a web page and do payment processing with Stripe or some PSP. So you get the equivalent workflows or the equivalent PCI scoping advantages there. Then if you're a company that wants to do something with the card data that isn't just taking it from a user and sending it to a PSP, you want to enrich it with information about the issuing bank or something, you need some environment where you can send a tokenized or encrypted credit card number in, do some compute, and then return the response. So we send in, for example, a credit card number, and we'll return, this is a Barclays debit card issued in the UK and all that other kind of info there. So the nice thing about Lambda is that you can just write these very nicely logically isolated pieces of code that, yes, you take responsibility for them, but you're talking about 20 lines of code or something versus an entire service or an entire cloud environment. So Evervault, and by extension AWS, takes responsibility for making sure the data centers are secure. They've got armed guards and attack dogs and all this kind of stuff. But from a developer's perspective, all you have to worry about is that 20 lines of code that you're deploying, rather than with EC2 or something, you have to worry about patching it, all the kind of vulnerability scanning. The kind of trusted compute base is massive because you've got hundreds of different services running in there. Whereas with Lambda, it's 20 lines of Node or Python or something similar, and that's all you have to worry about. So Lambda's been a great kind of foundation for us to build on there.
All right. So as a customer who's using your services or software, I guess, I just have to call a Lambda function? Is that what you mean?
Yeah, so we have a bunch of different primitives that basically anything you can do with plain text data, you can do with an Evervault token. So you can process it using your own code in an Evervault function, which is actually an AWS Lambda under the hood with some kind of restrictions on it. You can share it with any third party through a network proxy. So if you want to send a credit card number to api.stripe.com, all you have to do is create an Evervault proxy. We call them relay. We give you a domain name that's something like stripe.evervault.com. You send the exact same request through, except instead of sending the 16-digit card number, you're sending the token, and we just swap it out on the fly. So you can still interact with any third-party services. You don't really have to change how your application works. You're just changing a few domain names. So yeah, as I said, everything you can do with a piece of plain text data, you can do with an Evervault token.
And that Lambda code is hosted in my end, or you're hosting it? I just call it, I guess. I just invoke it.
To get the PCI descoping advantages, everything is managed and sort of hosted by us, which, in a lot of cases, people worry about self-hosted and on-prem from a security perspective. When you're talking about compliance, and especially PCI, you kind of want the complete opposite, where you want Evervault to look after as much of it as possible. And so even for some of these common use cases where people might be writing a Lambda to check a credit card bin or first 6 digits to figure out what bank it is, we try to just figure out what the common themes are there and just give people a dedicated API so they don't have to write that code. But the way we're kind of thinking about it long term is that for all these other kind of forms of PII or sensitive data, whether it's a credit card or something else, you're always going to be enriching it with some third-party data source. So we're focusing on credit card numbers and wallet private keys to start. But over time, you could imagine the same flows for a social security number and you want to run a credit check. If you tokenize the data with Evervault, it's secure, but you also get these other kind of product and engineering advantages from writing it and securing it through us in the first place.
Is Lambda PCI compliant then?
All of AWS, or pretty much all of AWS, is PCI compliant, but there's what's called a demarcation of responsibilities. So AWS are responsible for one part and you're responsible for the other part. So all the kind of everything except for the stuff that you run inside the Lambda is PCI compliant.
Okay, right.
And then we just try to kind of extend that demarcation of responsibilities. So for us, we get a lot of advantages from Amazon for PCI compliance. We still have to do a bit of work ourselves, and that kind of delta between what AWS gives you and what Evervault gives you is the kind of material value that gets passed on to one of our customers.
Right.
So yeah, it basically goes from 400 controls to about 20 in most cases, which is pretty material.
In terms of broadening it a bit more as an organization, I'm assuming there's too many Lambdas floating around, as the joke on the industry is. What are some of the other considerations from a security perspective you would put in those AWS environments on your side as someone who's providing the service, out of curiosity?
Yeah, so PCI has a lot of requirements around instance patching, vulnerability scanning, and so on. So everything that you deploy has to be vulnerability scanned. And there's all these kind of network scans that have to be run as well. So every quarter, for example, we just do those on behalf of our customers. For people that are using AWS Lambda directly, it gives you a lot of advantages because there's just far fewer things to patch in there. Like you might be using a couple of libraries in Python, but you're not kind of worried about patching the entire operating system. So going from an EC2 to a Lambda is a huge advantage from a compliance perspective, just because there's less stuff. And you're pulling, Amazon's Linux version 2 or whatever, rather than whatever version of Red Hat or CentOS or something that you're running yourself. So that's kind of the main thing. I think there's a lot of kind of table stakes stuff you can get out of the way quite quickly. Like when people talk about security features in AWS, they think a lot about like nation state attackers and kind of these weird ransomware attacks and so on. But most of the time, most of the data breaches are basic things like you're accidentally logging credit card numbers that go into this Lambda and so on. So things like log scrubbing and CloudWatch, just making sure that you're redacting everything wherever possible and you're kind of minimizing the size of the payloads. I think that's just generally good hygiene when it comes to this. But moving to Lambda alone is a pretty massive advantage.
So a startup which is building today and whatever they're doing in terms of, I guess, using Lambda as that foundation, they can have compliance covered in Lambda. And to your point, vulnerability management is limited more to the code itself rather than what OS am I running? Am I on the latest patch? Or is there whatever the patch Tuesday or whatever used to be called? So do you reckon the table stake, as we called it, for security, most of that can be applied directly using AWS native service? You don't really have to go for a third party as well if you don't.
Yeah, it depends. I think if you've decided you're going to become PCI compliant yourself, then definitely just kind of minimize scope and outsource as much of it as possible to AWS. We work with customers who just basically decide they don't want cardholder data at all. So for example, we run in AWS, but if one of our own customers is running in AWS, because they never touch credit card details at any point, their entire AWS account is out of scope pretty much. And we take on the responsibility. But if you've decided that you are going to make the investment to become PCI compliant, there's a lot of kind of quick fixes you can do so that out of the 400 controls, you're removing as many as possible. And then for the ones that are remaining, instead of worrying about months of engineering time for each thing, you can kind of just minimize a lot of it by not having to patch, doing log scrumming, all those kinds of things.
What's been your experience over the years of doing all this from a PCI compliance perspective? Do you feel like the auditors are at a stage where they're starting to understand the value that, hey, if I go cloud native, like if I'm using Lambda, my scope of, I guess, assessment is is predefined. Like I don't have to worry about the underlying piece because AWS is already PCI compliant. The same goes for the Nitro service OSs as well, or Nitro hypervisors.
Yeah.
Like the same with the Nitro hypervisors as well. Do they understand that, or did you guys have to kind of like go through some of the auditors to kind of find that person who understands it, or was there? Because where I'm coming from is the fact that a lot of people look at this, and the reason they sometimes hesitate to go out on that path to what we were talking about earlier, it's that it just gets too hard to convince another third party that, hey, I am PCI compliant. Look at what I've done. Well, how was that journey for you guys?
I think QSAs are definitely very comfortable with cloud native. They've been doing it for a while. A lot of companies, or most companies, are doing that now. So I think the number of audits that your typical QSA is doing for kind of like an on-prem deployment is definitely shrinking massively. So they're totally comfortable with the AWS primitives. I think the problem with PCI is because it also extends to point of sale. If you're a large kind of grocery store or retail store or something, you might have hundreds of different outlets, and then part of your audit scope is going to every single store to make sure that each point of sale terminal is compliant, or is using point-to-point encryption or something similar. That's when kind of the real complexity creeps in. I think for these kind of cloud native companies, auditors are pretty comfortable with it, but like the problem is you still have to evidence pretty much all of the 400 controls. Some requirements are just looked after by default. Like for example, if you're using cloud, you don't have to worry about physical security.
Or
you don't have to worry about the cloud physical security. So those kind of things just mean that the audit time is massively reduced. But I think QSAs are definitely comfortable with cloud primitives, but because it's a compliance framework, the kind of level of security is important, but it's kind of secondary to, does it kind of meet the spirit of the requirement itself? So I think in a lot of cases, some companies, including us, tend to go above board saying like, yes, it meets the spirit of the requirement, but it's also 10 times better. They're like, yeah, that's great, but it meets the requirement. That's kind of what matters. But yeah, QSAs are definitely comfortable with the cloud.
Awesome. Now, well, dude, where can people find out more about what you guys are working on? That's kind of most of the technical question I had. So where can people find out more about what you guys are working on, and what kind of what can you expect from the AI loft at AWS?
So we write a lot of kind of engineering content, not only about our product, but also how we built our product. So evervault.com/blog has a bunch of kind of deep dives on how we built our Enclaves product, for example, and how we built our core encryption engine. So if you're an engineer, that's some pretty interesting content there. If you just remove the /blog at the end, go to evervault.com, you'll see what the product is. But yeah, I think the big thing I'm interested in at the Gen AI Loft is just how people are using it for real-time processing. We do a lot of anomaly detection on things like scripts. So for example, you have to verify that any script that's loaded on a payment page hasn't been tampered with. In fact, as of March next year, we will. And that's not necessarily a real-time use case, but definitely curious to hear how large PSPs are doing kind of real-time fraud detection at scale. That's a pretty hard challenge when you need to get a response back in 10 milliseconds or 50 milliseconds or something very fast like that.
10 milliseconds?
Yeah, I mean, issuers have 50 milliseconds to reply to a payment authorization. So yeah, people expect payments to be fast now, and you can't send a request to openai.com or something that quickly.
Oh, wow. Speaking. Okay, I did not realize it has to be that quick. It's like, okay, cool, but I appreciate you sharing that. I'll put the links in the description show notes as well, man. Dude, thanks so much for coming on the show.
Sounds good. Yeah,
Thank
likewise.
you. Thank you for coming. Thank you for listening or watching this episode of Cloud Security Podcast. We have been running for the past 5 years, so I'm sure we haven't covered everything cloud security yet. And if there's a particular cloud security topic that we can cover for you in an interview format on Cloud Security Podcast, or make a training video on tutorials on Cloud Security Bootcamp, definitely reach out to us on info@cloudsecuritypodcast.tv. By the way, if you're interested in AI and cybersecurity, as many cybersecurity leaders are, you might be interested in our sister podcast called AI Cybersecurity Podcast, which I run with former CSO of Robinhood, Caleb Seamer, where we talk about everything AI and cybersecurity. How can organizations deal with cybersecurity on AI systems, AI platforms, whatever AI has to bring next as the evolution of ChatGPT and everything else continues. If you have any other suggestions, definitely drop them on info@cloudsecuritypodcast.tv. I'll drop that in the description and the show notes as well, so you can reach out to us easily. Otherwise, I will see you in the next episode. Peace.